Hello, algebra students, or should I say good morning? It's only about 5:11, but that's okay. It's time to make a video. So we've been working a lot with these negative exponents, and I'm going to go through two problems really slowly, showing you step by step, and then there's a short video quiz, so this video shouldn't take very long. So the first thing I noticed on problem number one is that I've got this negative exponent out here. That kind of bothers me because this whole negative thing. So I remember Mr. Laurence saying that a negative exponent means to use the reciprocal. So I'm going to find the reciprocal of everything in the quantity. If I get that reciprocal, then this should change to a positive, right? Because remember, 2 to the negative third was the same as 1 over 2 to the third, right? And aren't they reciprocals of each other? Sure. And notice that the negative changed to a positive for the exponent. Okay, of course it does equal 1/8, but the idea of the exponent changing comes from that example there. So first thing I'm going to do is I'm going to flip this fraction inside the quantity. So my numerator is going to become 20 x to the 7th, y to the negative third, z to the 9th. And in the denominator, we're going to have 8x to the negative third, y to the 5th, z to the 9th. And then that too can change to a positive. Now I've got some negative exponents inside my quantity. So I'm going to highlight them. Kyle Robinson was doing a real good job of picking out the terms with negative exponents. He was doing a real nice job highlighting that. Now remember, those terms with negative exponents are going to move. If it's in the numerator, it'll go to the denominator. That'll be the same as finding the reciprocal. If it's in the denominator, it'll move to the numerator. So when I rewrite it, I'm going to be very careful, very deliberate here. I'm going to put in my numerator a 20. I've got an x to the 7th, but now I'm going to have this x to the 3rd. Put them next to each other because I know I got to multiply them. Then I have a z to the 9th. And in my denominator, I'm going to have an 8. The x is gone. That y to the 3rd is moving down. There's a y to the 5th there. And then another z to the 9th. That's raised to the 2nd power. So now I'm going to simplify inside the quantity as much as possible. I would not go and square everything. You'll make the problem more challenging. So the first thing I notice right off the bat is I have a z to the 9th divided by a z to the 9th. They cancel out. Now, if you wanted to do it the long way, you could say, well, z to the 9th divided by z to the 9th. That's the same as z to the 9 minus 9, which is z to the 0. And we learned that any non-zero number to the 0 power is 1. In other words, there's 2 1s there. They're not going to show up in my answer because they're going to be multiplied by other terms, but that's what happens to the 2z to the 9ths. All right, so the z's will be gone. I won't have any z's in my answer. Let me simplify 20/8. 20/8. I think the GCF is going to be 4, and so if I divide 20 by 4, I get 5. 8 divided by 4 is 2, so I have a 5 over 2. Notice I didn't go mixed number here. Don't go mixed number. Leave it as an improper fraction. All right, I've got x to the 7th times x cubed. Well, that's x to the 10th. I have y cubed times y to the 5th. That'll be y to the 8th. And the z's are gone, so I don't need as long of a fraction here. Let me close it off. Now I have to square everything. Should really put equal signs in here. So 5 squared is 25. X to the 10th squared. X to the 10th times x to the 10th is x to the 20th. Always think about what it means. Don't rely on shortcuts. 2 squared is 4. 2 times 2 is 4. Y to the 8th squared. Well, that means y to the 8th times y to the 8th, or y to the 16th. And there you go. There's the fraction. There's your answer. Simplified form. All right. Of course, we're assuming x, y, and z don't equal 0. All right. Number 2, same thing. I'm going to, first of all, take care of this guy. I don't want a negative there. So I'm going to find my reciprocal, which will be 24x y to the negative 5th z to the 8th. I'm going to put that over 36x, y to the negative 10th, z to the negative 3rd. Now it'll be to the first power, which really means the parentheses are unnecessary. So I'm going to drop them out of the next step. Okay, so I'm going to do some moving of things with negative exponents. So let's see, I got something there, and I've got something there. So remember, if it's in the numerator with a negative exponent, he's going to the denominator. Terms in the denominator will go to the numerator, just like that. And their exponents will change when they do that. All right, so remember, I can drop out these parentheses because raising something to the first power isn't going to change anything. Normally, I would keep them in there. So I'm going to have a y to the 10th in the numerator, a z to the 8th times a z to the 3rd. In the denominator, I'll have a 36. I'll have, oh, I lost my x, sorry. I'll have an x down here. I'll have a y to the 5th, and that'll be it. All right, so now I'm ready to simplify. And again, the first thing I noticed, and I think I did it subconsciously, was that those x's are going to cancel each other out. They're not going to be in the problem anymore. Okay, so let's simplify 24/36. Remember, find the greatest common factor. So many of you start at 2. You're starting at the wrong end. Start at 24. 24 does not go into 36. 2 and 12. Does 12 go into 36? It sure does. 12 is the GCF. So many of you just grab 2 or 3 or 6 or something comfortable. Start at the high end and work your way down. I mean, if I list all the factors of 24, excuse me, all those numbers I just mentioned show up, but only one of them is the greatest common factor. And see, it's up here at 12. If you start grabbing down here at 3, 4, or 6, you miss it. Okay? All right, so I'm going to divide 24 by 12, and I'm going to get 2. 36 divided by 12 is going to be 3. The x's have canceled. I've got y to the 10th over y to the 5th. Well, that'll be a y to the 5th left in the numerator, won't it? Because y to the 10th divided by y to the 5th. Right, that'd be like 10 y's over 5 y's. They'll cancel. I'll have 5 y's left in my numerator. All right, the z's will be z to the 8th times z to the 3rd, which would be z to the 11th. And there we go. That's it. Only the 3 is left in the denominator. Okay, so I modeled that for you again. Here's 3 problems. The first 2 are exactly what I did in class, and the third one is something we've talked about quite a bit. So go ahead and get it done, and I will say have a good night, everybody.